Okay, so now we're going to look at proving using some of the sum and difference identities. This is similar to what we did before, where basically you just kind of work on one side and prove that one side is equal to the other side. So what we'll do here is actually work on our left-hand side using our difference identity for cosine and prove that this is equivalent to this. So this is going to be our A, and this is going to be our B. So if you'll follow the difference identity for cosine, it starts out as cosine A. So in this case, that would be cosine X times, so I'm going to use parentheses to indicate the multiplication, cosine B. So this would be cosine of just 2 pi. Now the way these work, you've already decided which identity based on this being a plus or minus. So B is just going to be this value here of 2 pi. So you wouldn't say negative 2 pi. Okay, plus, and then sine A. So that would be sine X times sine B. So that would be sine of 2 pi. Now when I simplify what I have on this side, I should get it to simplify to equal the cosine X. Now, this one and this one where you actually have exact values, we need to replace the value in those two situations. Okay, so I've got the cosine X times. Now, cosine 2 pi, that's not one that's straight off of your values, but now that we have studied our cosine graph, you could just refer to it. Like if you go back to just plain cosine X graph, there's no amplitude period, none of that. And you look at just that one cycle. Of course, 2 pi is that very last tick mark, and on your cosine graph, at that last tick mark, your cosine stops at a value of y equal 1. So that's what you're going to replace that with. Okay, then the same concept that we can use here. So if you refer to your sine graph, again, 2 pi is that last tick mark. So the location of that point is actually right on the x-axis, so the y value there would be 0. So of course, multiplication here is just going to give us 0. So that term is gone, and 1 times cosine is just cosine. So there's where we got the proof that it does equal what we have on the right-hand side. Okay, one more of these. All right, going through the same process, but we are going to have to expand both of these, so we'll have to use the sum identity for cosine and the difference identity for cosine. Okay, so this is, again, my A, and this is my B. So following the sum identity for cosine, I would have cosine A, so that would be cosine of pi over 3, times cosine B, so that would be cosine X, minus, and then sine of pi over 3 times sine X. Okay, so all of this is this first part. So now I bring down this addition sign, and now I follow the difference identity for cosine. So this is the A, this is the B. So I would have cosine of pi over 3 times cosine X plus sine of pi over 3 times sine X. Of course, when I'm done simplifying this, I hope it simplifies to be cosine X. All right, one thing that you should notice is that this term and this term, of course, are just, are considered like terms, but, one would have a coefficient of -1, the other one +1, so those two are just going to add out. Just go ahead and mark those out and get them out of the way. Now, I do have two of those, so you could add those together, but you could do that first if you wanted. But another thing you could do first is replace your values here. So this would be 60 degrees. So cosine 60 degrees is 1/2. So I can say that I have 1/2 times cosine x. Bring down your plus sign. Again, cosine 60 degrees, so that would be 1/2 cosine x. And 1/2, I mean, these are like terms, so 1/2 plus 1/2 is just 1, so that would just be 1 cosine, of course, equals cosine. So there proves that identity.